Can you solve this Maths Olympia problem on the board? This is very simple. Here we are told to do 2 power m plus 4 power m plus 8 power m is 39. For us to do this, this is very, very simple, okay? Because we know that 2 power m plus, we have 4 now. 4 can be expressed to be in base of 2, right? Which is 2 times 2. 2 times 2 is 2 squared, is 4. So we have it as 2 squared. Then already existing power m. Then plus 8 can be seen as 2 times 2, 4 times 2, 8, 2 power 3. So we can write it as what? 2 power 3, already existing power m, and that's equals to 39. Okay? So when you have this, you simply recall the laws of exponents. The laws of exponents says that this law of exponent that a to the power of m, then raised to power n, can be seen as a to the power of n, then raised to power m. Since it is multiplication, we can flip their what? Positions. So what do we do here? We'll now write 2 power m. We need every term here to be in terms of 2 power m. So we have 2 power m plus 2 power m. We apply this law, then all squared, bringing out the 2, then plus 2 power m, then all cubed, and that's equals to 39. Okay? So if you have this now, this is very simple. Please do well to subscribe, like, and follow my YouTube channel. So if you have this now, you can now say, let our y be equal to 2 power m. Okay, so all we need to do is to write the whole expression equation to be in terms of what? Y. So we'll have it as, this is 2 power m, so we'll have it as y plus, this is 2 power m, we have it as y squared, then plus, this is 2 power m, we have it as y cubed, and that's equals to 39. Okay, so since we have this now, we can now what? Arrange. So we can now simply start with y cubed plus y squared, then plus y, rearranging the order. Then we now need to equate it to 0, so we subtract 39 from both sides, minus 39, and that's equals to 0. Good. So you can now see that this is clearly a cubic equation. So what do? We find a way to simplify this whole term to suit a cubic term. So we simply know that 27 is a cubic term of 3, 9 is a square term of 3, then 3 is a linear term of 3. And we can actually achieve it from what? 39. So what do we have to do? We have it as y cubed plus y squared plus y, then minus, we'll now use 27 plus 9 plus 3. You know, all this is equals to what? 39. So nothing changed. So what do we do when we have this? We distribute the negative sign, okay? If we distribute the negative sign, we have it as y cubed plus y squared plus y minus 27 minus 9 minus 3 is equals to 0. So what do we do now? We have to rearrange the whole equation. So what do? We have it as y cubed, then we get the 27 minus 27, okay? Then plus y squared minus 9 for the 9, then plus y minus 3 equal to 0. If you look here, we have 27. 27 can be seen as 3 times 3, 9 times 3, 27, which is 3 cubed. So we have y cubed minus 3 cubed, okay, plus y squared minus 9 is 3 squared, okay, then plus y minus 3 equal to 0. So let's simply put them in a bracket, okay, equal to 0. Then before we move forward, we should know a special identity. In that identity, we have it that we have that we have the identity to be a cubed minus b cubed. The expansion is always a minus b into a squared plus ab plus b squared. That's the expansion in a cubic term. Then if you have a square difference, we have it as a squared minus b squared. We apply difference of two squares as a plus b into a minus b. Okay? So if you have that now, this is simple. So what do we do here? This is a cubic term. This is clearly a difference of two squares, and this is a linear term. Let's apply this particular rule. Okay. So what do we have? We have it that our a will now be y, and our b will now be 3. So what do we do? This is very, very simple. So we have to do a bracket. We have it as uh, y minus 3, okay, because we have already assigned this into y squared. We have it as y squared plus uh, 3 times y, okay, then plus minus 3 squared, okay. That's for the expansion for the cubic term. Okay. Then we have this to be, we go to the difference of two squares. We have it to be y minus 3 into y plus 3. Okay. That's a positive sign here though. Then plus y minus 3. All is equals to 0. You can see we have it as y minus 3. This one is y squared. 3 times y is 3 times y is, which is y minus 3 into, we have it as y squared. We have it as 3 times y is plus 3y. Then we have it as minus 3 squared is what? Plus 9. Okay. Then we'll go to the next one. We have it as plus. We have it as y minus 3. Y minus 3 into y plus 3. Then the last one is plus y minus 3. And everything is 0. Good. This is how it looks like. Then if you understand one thing, y minus 3 is always common in each of the expression. So we can factor it out. So if I factorize y minus 3, okay, I'm left with y squared plus 3y, then plus 9. The next one that follows is plus y plus 3. The next one that follows is 1, and that's equals to 0. Okay, good. If you have this, we have it at y minus 3, okay, into y squared. This is the highest y squared. Then the next thing we have is 3y plus y is basically 4y plus 4y. Then 9 plus 3 is 12. 12 plus 1 is 13 plus 13, okay, equal to 0. Okay, so this is how it looks like. We have it as y squared plus 4y plus 12 plus 1 is 13. Okay, so okay. So in this expression, when two terms multiplies to get 0, that means y minus 3 is equals to 0. Or we'll say that y squared plus 4y plus 13 is equals to 0. That's what we got here. So this one is clearly that y is equals to 3 when you add 3 to both sides. Okay, so that's good. Then the next thing we have to do is the next one. But if you look at this, if you check the discriminant, which gives the nature of the root, this is b squared minus 4ac. So you see that b is 4. B is 4. You have it as 4 squared minus 4 times a is 1, then times c is 13. Okay? So we have it as 4 times. So we have it as 4 squared is 16, then minus 4 times 1 is 4, 4 times 3 is 12, 4 times 1 is 4 times 1 is 4, plus 1 is 5. We have it as 52. And this is basically giving us negative uh, uh, 12 minus this is 6. 5 minus 1 is 5, is 4. Sorry, 4 minus 1 is this. So you have it as negative 36, which is giving an imaginary root, okay, or a complex solution. And that's not what we want. So we basically use this term. So what do we do when we have this term? Remember, we said that y is this. So since y is 3, that means 2 power m is equals to 3. Okay? So to get the value of m, which is the one we're looking for, we just have to do what? We don't actually need this solution because of the nature of the root. So you have it to be, you take the logarithm of both sides, you have it as log of 2 power m is equals to log of 3. Okay? Then logarithm allows us to multiply the power to the exponent. So what do you have? You have it as m log 2 is equals to log 3. Okay? Then the next thing you do is to divide by log 2 and divide by log 2 over log 2. Okay? So after that, you use change of base. See the actual value of m is the m log base of this of what? 3. And that's the what? Answer.